As always, again, thanks for joining us. If you're not a member of ADI, as I always say, we highly encourage you to join our community officially. For DSP, it's $350 a year. That gets you the 3 issues of Distiller Magazine, the printed resource directory, and then some heavy discounting for our annual conference and also for the spirits competition, which is actually the submissions for the spirits competition is currently open. I want to introduce Scott Moore, who is the founder and president of Dalkita. He's agreed to talk to us today. And Scott, I appreciate you being here. Safety, obviously, in a theoretical sense and beyond, everybody knows it's important, but I think sometimes it doesn't quite get the respect out of the gate, maybe that it deserves. Years ago, before I was in this industry, I remember I was working for this small company, and they had a big company meeting and rolling out some initiatives, and all the big wigs were there, including the safety president. And I don't know, the negotiations got heated, and this guy stood up and banged his hand on the table and said something along the lines of, well, damn it, I'm a company president. And the guy beside me, who was one of the older, crustier, saltier guys in the warehouse, just sort of leaned in, and under his breath, he goes, yeah, of safety. So, but it is hugely important, and there's a science to it. And so anyway, thank you for being here and being part of this today and helping lead this discussion. Oh, and before we get into that, I'm sorry, if this is your first time doing a webinar with us as an attendee, there will be time at the end for a Q&A. So please put those questions as you have them in either the chat or the Q&A field, and I will pitch those to Scott at the end of our session. Again, sorry to have interrupted you, Scott, but I wanted to get that out there because I'd forgotten to say it. Thanks, Scott, for being here.
Oh yeah, happy to be here. This is a pretty exciting. It's my first time doing a webinar, so we'll see how I go, not being in a room with all these folks. But let me see if I can share my screen here and get this show on the road. Right. Am I sharing correctly?
Yeah, looks good. Looks good to me. I will say this as a public service announcement too. For those attending, I can't. We've had in the past with presentations. As an attendee, you ought to be able to maximize what Scott is sharing. It looks maximized on my screen, and I think Scott probably on yours too. But every now and then we'll have an attendee say that they can't see it. The attendees should have the ability to increase that size and to be able to see them. So anyway, I just wanted to say that. But yeah, looks good to me, Scott.
Okay, sounds great. Well, as John mentioned, there's going to be a lot of text and so forth in this. We don't imagine you'll be able to read it during the entire time. So by registering, you will get a copy of this presentation to look through in the future. And that's what this scan code is there too. It does the same thing, although I don't think it's very necessary since John's got that figured out. So here we go. And these are my qualifications. I'm an architect. I've been at this about 30 years or so, and maybe 20 of those have been specializing in distillery design and construction. Also a general contractor. I feel like that, myself and Matt, that makes us both better contractors and better architects because we know both sides of the coin. And that sort of leads me into like an overview of the content here. It's going to be a little, some of you may or may not have seen our presentations at various venues such as ADI, but this content is going to be a little bit lighter on code specifics and a little bit heavier on concepts. I always like to say that, laws of man are one thing, but laws of physics are the ones that we really have to follow And of course, there's no substitute for good old common sense. And that's kind of where we're going to be focusing on here with a smattering of technical data to show you how that those laws of physics and common sense are addressed with regulations. So we've got some goals here on the screen. And to be more specific than what I just said, and some topics that will be covered. I think that you can read through these, and we'll go over kind of everything as we get going. So, the first law of physics that we want to look at is, what exactly are the physical attributes of alcohol. Alcohol is a little bit different than um, other flammable liquids in that it's what is referred to as water miscible. So I think common sense will tell us that 20% ABV is a lot less flammable, a lot less hazardous than 96% GNS. And so the codes don't really recognize that too well. The codes identify pretty much anything over 20% as needing to be treated the same as a flammable liquid. So we've got these three classes of flammable liquid that are defined in the code, and your alcohol is going to be a 1B or a 1C. It's never going to be 1A, and that's because alcohol at sea level boils at around 173 degrees, and a 1A liquid, which would be more like gasoline, boils below 100 degrees. So let's also talk about, my favorite extracurricular class here. What is really burning? Does the alcohol, the liquid doesn't burn, and what burns is the vapor. And so if you look at this picture of the flame there, it's riding about an eighth of an inch above the surface of the liquid. And what's happening is that once the flame gets started, it heats the alcohol, and the alcohol rises to the top. And in that gap there, uh, we have too high of a concentration, that eighth inch gap of fuel and air to burn. And then above that, where the flame is where we're within the flammable range. So the flammable range is between 3.3% and 19% for alcohol. And we don't really worry about getting over 19% because you'll know that pretty well if you're in that high of a concentration. But the codes want us to stay under 25% of that flammable liquid. So what could happen if you do fill a space with a concentration within that flammable range is called a deflagration. A deflagration is the rapid burning of a fuel and air mixture. So that's what takes place inside the cylinder of an automobile, a gasoline or diesel powered automobile. We don't have that in electric cars, obviously. Um, but there's a couple kinds. A deflagration can lead to explosive conditions, and the difference between a deflagration and a detonation are kind of the technical term is that a deflagration is subsonic, whereas a detonation occurs at faster than the speed of sound. And deflagration is the burning of the fuel air mixture, whereas a detonation is a chemical reaction. So we're not going to have a detonation. We will have a deflagration with potentially explosive concentrations. What happened at this rather famous distillery was that they didn't have air movement in here enough, and they walked away. And this is a CIP fitting on the column still that developed a pinhole leak, and this still became a fuel injector. And then the alcohol vapor found a refrigerator motor that kicked on, and they had a big whoom sound. No one was hurt in that, thankfully. So hopefully everyone is familiar with the triangle, the fire triangle. It's a pretty simple concept. You need three things in order for there to be fire: heat, oxygen, fuel. And so what we talk about is, if we remove one of these things, then we cannot have fire. So that is sort of the key to safety is making sure that we are unable to complete the fire triangle. Now we can't remove oxygen. We'd find it hard to breathe. Um, but we can remove heat or fuel. And the in my opinion and experience, removing the fuel is the best, most sure way of assuring that you cannot complete the fire triangle. Here's where common sense comes in. This is a picture, where there's a lot of common sense things that are not taking place here. We've got a still that is homemade. The top blew off. It's spraying alcohol vapor on an electric fixture, a light. There's someone who is in a confined space, trapped themselves between the still, a ladder, and some tanks. And then, who knows why we've got that on a forklift. There's just a lot of things that are wrong with this picture. And this was an employee that did suffer some burns. Um, and I think it's important to understand that while the distiller may have the common sense, but perhaps someone working in the distillery doesn't. And so this is where standard operating procedures and boring safety talks come into play to prevent this sort of thing. So hopefully somebody here has heard of the electric sombrero of death. And that was a term that was coined a few years back by our organization to describe this image in the upper right-hand corner, which is from NFPA 497, and it shows where you find what is called the classified area. It recognizes that alcohol vapor is heavier than air, and so within a 5-foot radius of a potential source of alcohol vapor release, such as your still head, or in the case of that previous slide, that CIP fitting, within 5-foot radius of that is classified, and electric equipment that is inside that area needs to, by code, be um, basically explosion proof. Then it also recognizes that alcohol is heavier than air, and so within a 25-foot radius of that source, but within 3 feet of the floor, that danger area spreads out. As you get below grade, which is what this little blue section is, the alcohol can't dissipate horizontally, and so the classified requirement increases. This is a video that sort of explains what a typical distillery might have, and it also happens to be a representation of the physical and visual connection that a lot of our clients are trying to achieve between their production area and their tasting room and their offices. So we've got your tasting room with a view to the prettier parts of the distillery. Up above on a mezzanine, we've got the small micro distillery's office where they can observe what's going on in both the production area and the distillery. They've got a direct access out to the production area. And here we see some vapor leaking from the still. This is, by the way, you can see it's labeled Clammy Distillery. Everything is going wrong here. But there, 25 feet away from the still is the source of a spark. Can't quite tell what that is. Looked like a generator or something. Barrels do present a vapor issue, but it's very minimal. When we have done studies about based on the angel share recorded data that is necessary for the TTB, it indicates that a very, very low level of ventilation is sufficient to deal with a with normal barrel evaporation. And when we get into a situation where we're storing totes, over they may be, we or the maximum allowable quantities, we put them in a special room. There's a pit there, and the risk of vapor accumulation is generally due to evaporation from a spill. It's higher than the risk from barrels normally off-gassing, but lower than the risk presented by the still. The still is your biggest opportunity to have a vapor release, and really the level of ventilation needed to overcome a release from a malfunction in the still is going to be highly dependent on your operation. So if you are reprocessing GNS by putting 50% GNS and water into the still and distilling it over a 1 hour period to create your own vodka in compliance with state and federal laws for being a distiller, that's going to produce a lot more alcohol per minute and require higher level ventilation than if you're putting 10% wash in a still and distilling it over 8 hours to produce a whiskey per se. So when we do provide the ventilation, the concept is that we want to sweep the alcohol vapors across the room. And so we provide, and the code dictates that the exhaust intake be within 12 inches of the floor. And that's because alcohol vapor is heavier than air. And so sometimes we'll put, I don't know if you can see my cursor now, but sometimes over there where there's the dimension of 3 feet, depending on the size of the area, we'll put an intake low that is a lower percentage of the intake makeup air than the intake that's high. And the idea behind that is to sweep across. Now, on a physics level, this works for alcohol, but it is counterintuitive to most building designers and engineers and contractors and so forth who might be wanting to use ventilation to circulate air to deal with heat buildup, where we all know heat rises. So you would put the exhaust high and the supply low. This is an image of what might be found in a lot of different buildings. And to make this high exhaust work better for alcohol vapor, it's a simple matter of extending the duct down to the floor. When we design a ventilation system, an exhaust ventilation system, this is what they generally look like. And so we've got the duct going down to within 12 inches of the floor. And you'll notice both of these have this other side duct. Well, the reason for that, excuse me, is that these are in a containment area. So where you have a potential for a spill, you're required to provide secondary containment. And one of the most cost-effective ways to do that is with, sort of a bermed area or a bathtub above grade. Well, imagine there were a spill of alcohol and sprinkler water that covered the bottom of that opening in the duct. Well, suddenly now that blocks your exhaust from happening. So at that point, there's a damper, a barometric damper is what's shown on the right side, and electronic damper is what's shown on the left side to open a secondary inlet so that now we're exhausting from 12 inches above that surface of the surface of the puddle.
Scott, can I stop you real quick and just ask a question about codes and regulations? When you're talking about, I know you're talking a lot about the science, and then you're applying some of the regs for, how far off the ground or that the intake is low because alcohol vapor is heavier than the air. But when it comes to the codes and the regulations, have you found that that's a federal code that applies to everybody? Are there then state specific codes that augment the federal regs in some way or another, or is it just easy one rule book applies to everybody?
Well, that's an excellent question, and I'm glad you asked it because the federal codes that allow you to get your DSP, they say next to nothing about safety. The federal government, they just want their money. They don't care if you blow up. Well, they do a little bit because then you can't pay them taxes if you blow up. But the one thing that the federal DSP codes and most state alcohol regulatory codes do require is that a facility be in compliance with their local building and fire codes. That's where you get these regulations that I'm talking about, you have to exhaust within 12 inches of the floor. In the US, we have code writing authorities or they're really private organizations that write the codes, the International Code Council and National Fire Protection Association. And then local states, states in some cases, and then cities, counties, other local jurisdictions adopt those standard codes and apply them to you. So, it's interesting to think. We've seen situations where someone, for instance, purchases a building like this. It's all ready to go, and they put their distilling equipment in there. No problem. They've checked with their zoning department, and distilling is okay. But what has happened when they put the alcohol in there is that they've changed the occupancy. They've changed the use from what it was before, which might have been storage, to manufacturing or a factory occupancy. And if they exceed the maximum allowable quantities of flammable liquid, then they've changed it to a high hazard occupancy. That legally triggers a building code application, even if there's been no real physical changes to the building. And so sometimes we do see people get their first fire department inspection and a big surprise that they thought they had complied by meeting the zoning requirements, and then they hadn't. So that's where that comes from. It's your state and local codes, and what you want to do is contact your municipality to find out exactly which codes have been adopted and how your local jurisdiction has modified them. Did that
And
answer your question, John?
it did, and I would add to that, without disparaging local municipalities, if you're a new distillery in an area, and maybe you're the first or only distillery in that area, you can I want to try and say this in a polite way. You may be able to articulate it better through experience, but I think most people can expect a little static from your local, because they won't, through no fault of their own, they will have had no experience applying whatever their local demands are to a business. I mean, any fire marshal in Kentucky is probably going to know it like the back of their hand. But if you're the first distillery in a small area and they're not familiar with all of that, there was two sides of that coin. One, you may know the regs better than the person inspecting you sometimes, and you may have to put up a little bit of a fight or negotiate with them to get it right, depending on their interpretation of it and how they apply whatever the code is to an industry with which they may not be as intimately familiar as, if you were putting in a machine shop or just a standard civilian office of some type. Do you agree with that, or you think that's too much of a cautionary tale?
No, I do agree with it 100%. And I am going to share with you now my opinion about the best way to deal with that. So, we want to consider our code authorities, our authority having jurisdiction, or AHJ, as a team member. They're a part of a community that you're going to become part of. And so I think that needs to be respected. And generally, you can develop a very good relationship with these people. And the key to that is honesty. And by honesty, I don't mean simply, telling part of the truth. You want to educate them as to exactly what's going on here, how your process works, what it is, and um, where it's regulated in the code. And then when you approach these folks, there's a temptation If you've got a good personal relationship with an AHJ, to just say, hey, tell me what I got to do. A couple things could happen. They may tell you that you have to do something or that you don't have to do something that you really should be doing. And then if they find out later on, they're going to feel like they're burnt. And so they're going to feel hurt and injured, like they did something wrong. They're going to have a sense that they may be liable for some accident that could happen there. So you want to be upfront with them. And the other thing is that you might find is that they, say, hey, what do I have to do? They might look at the code, and since they don't understand and haven't looked at this, they might just say, well, you're going to be, for instance, a 1A flammable liquid. That's the highest, regulated thing. And we've told you that you're not, and you wouldn't want to follow those regulations. So, and once they've said something, it's really hard for them to back off of it. So, what we really like to do is write a detailed description about how your process works and then tell them, oh, this is wash. Wash is essentially beer. Here's in the code where it says that it's not flammable. It may say in this section that it has to be treated like a class 2 combustible liquid, which it technically is based on its flash point and boiling point. But there's another section that says it doesn't have to be treated that way because it has no fire point. Class 2 combustible liquid also applies to diesel fuel. And obviously, there's a big difference between alcohol and diesel fuel. So, developing a relationship is important, and developing one based on trust and educating your local AHJ. Personally, at Dalkita, we prefer to be the first one in because often if you're the second one in a jurisdiction or even the third, someone has really screwed them over before, and you're having to work uphill to regain that trust that they've lost in the industry due to what someone else may have done to them. Um,
Got it.
yeah. So, okay. All right. Now, electrical conductivity. Let's see. This is about static electricity. So, in the fire triangle, what we're talking about here is your heat source. Okay. Um, And when we're talking about ventilation, we're talking about your fuel source. So the ventilation removes the alcohol vapor faster than it can build up. So heat source or not, there's not going to be an opportunity to complete that fire triangle. Um, the code requires also that we mitigate the heat source in several different ways. And one way is to eliminate static electricity. So as a liquid or a grain solid can move through a pipe, it can develop static electricity. And so if that pipe um, is not metal, it's not going to be able to conduct that static electricity. So you can actually get a static charge coming off of a garden hose, for instance. Well, the right kind of hose has a wire in it that can then be with the tri-clamp fitting connected to metal apparatus. And the idea is that we want to bond all those things together and then ground it. Alcohol falling through the air can also build up static electricity. Now, at the scale that we see here, where it's, pouring a shot glass, you're not going to have a problem. But if you're filling a 10,000 gallon tank with GNS and you're dumping it in from the top, you really could create a static buildup in that liquid stream. So that's why we fill from the bottom. Um, here's a image of a pipe with liquid going through it to kind of make the point that, that pipe could develop a static charge. When we're looking at this is a screw auger for perhaps grain, we're looking at the same thing there. And then we've got totes, the plastic totes, which is a whole nother story that aren't allowed to be in the distillery, surprise, surprise, on a permanent basis. And your metal totes, which are. So these containers need to be also grounded. Um, I don't know that this is really about static electricity, but it's a cool picture. And what we're seeing here is a deflagration. We'll show you another some more images of this too. But this is a big concept, is that, I like to say it's the difference between the potato gun and the flamethrower. Um, this is a flamethrower model where he's got a big ball of flame at once. That's a deflagration, but it's not confined, so it's not an explosion. Um, this is a symbol for grounding. And when we do ground, what we need to do is it's grounding and bonding. So we want to, first of all, bond all the distillery equipment that has over 20% alcohol together. And that can be done through the piping, fittings, supports for wiring and so forth. And where there is a separate, where it's not possible to get a continuous bond, electric bond between equipment, then we can add grounding wires. And the best way to do this is to ground it to the main electric service symmetry. That way you've got an electric potential for your bonding and grounding of your equipment that is the same as the electric potential for the building. So that building electric service is going to be grounded in 3 of these 4 ways, generally attached to building steel, connected to a water pipe before the meter or before the shutoff. There's a UFA rod, which is a piece of rebar that's cast into the concrete foundation, which is required in newer buildings. And then we've got what most people are probably familiar with, the copper grounding rod pounded into the ground. And the way to be sure that you have achieved the proper bonding and grounding is to have an electrician test the system for resistance as per the National Electric Code. When we've got portable pieces of equipment, we want to be able to have alligator clips and jumper cables to bond them together. And these are some different fittings. This is some images of hoses that should be used with high alcohol content material. Here we're talking about the possibility of splashing, and then this chart is intended to kind of demonstrate that scale really matters. And that's a big thing that's lacking in the code is an understanding of scale. That's something that is important to educate your AHJ about, is that, hey, we are not Jim Beam. Well, hopefully one day, but this is a smaller operation and the safety requirements really are different. And so this is talking about ways to prevent that splashing. This slide talks about agitation. And it makes a point that it is possible, if you've got a mixer and, say you're using a mixer to increase the rate at which your alcohol and water molecules bond to one another for a speedier attenuation to reach your proofing goals. And that's okay as long as we don't have any electrics inside of this. I know Bill Owens likes to tell a story about a guy who stuck a hand-operated drill into the top of a tank, and the sparks from the drill motor caused an explosion. That's a common sense thing. If you're using a piece of equipment like that, I think it'd be fun if everyone has a drill and they turn out the lights at night and run that. You can see a pretty neat light show inside there. But this is okay, but you just need to be cognizant about the fact of what's going on, and this is why this vessel needs to be bonded and grounded. I said earlier that plastic totes aren't allowed with the higher proof spirits. They're approved for transportation, and that's what all your GNS comes in this volume size. And what needs to be done is that it needs to be transferred for permanent storage or long-term storage into stainless steel. Um, Plastic drums are okay, provided you have sprinklers, water, and that's because the code recognizes the difference between water miscible alcohol and something like gasoline. So a common thing that we put into our distilleries is this cord reel, so that you can, that would be then attached to the bonding system. Excuse me. And then you can clip this to a portable tank. We usually have these where we have alcohol loading and unloading into tanker trucks. So now we're going on to dust, and uh, you may or may not have heard the term combustible dust, but we're not talking about what builds up on your living room table when you have been gone on vacation for a month. We're talking about grain dust. And grain dust is of the size and type that it is combustible, and we know that. So what we want to do is prevent a situation where we can have an explosion. The difference between, we've got, instead of the fire triangle, we've got this dust pentagram, and this confinement is the real difference. Confinement and dispersion. So the confinement concept is important also for alcohol vapor. And what the dispersion is getting at is that you may have a small explosion, as shown on the lower left image, and that could then loft the dust into the air, creating a secondary explosion. And, this is my favorite high school chemistry teacher. So what you see there, I'll let it play a couple of times because he's dumping, I think it's just regular flour onto that match. Look at the size of the flour coming down, the size of the dust compared to the size of the fireball. So when you have a deflagration, whether it's the rapid burning of dust as a fuel in air or alcohol vapor as a fuel in air, the, that process expands. And so were he to have poured that into, say, a coffee can, it would be a much different um, video than the one where you see it expanding into the air without confinement. These are some of the items that can contribute to that heat source of your fire triangle. Any kind of heat, like an overheated bearing, your non-classified or a non-explosion proof electrical, lightning, static, electricity, and hot work, which is welding, grinding. So this is an image of, where you might have your dust, and we've got some concerns at fittings. We've got some concerns, where there's an open uh, part of a component and the mill, obviously. Another thing, we talked about the sombrero of death. Well, with dust, it's more the electric toque of death for those Canadians in the audience. The shape is more of a dome. And when we have an overlap between the alcohol classified area and the dust classified area, it creates what is termed as a hybrid mixture. So if you can imagine, you've got dust particles that are coated with alcohol vapor, that, can become a lot more flammable than either of those two things on their own. So, whereas with dust or alcohol vapor, the regulation wants us to stay under 25% of the lower flammable limit. If you do have a potential for a hybrid mixture, you have to stay under 10% of the lower flammable limit or the maximum explosive concentration, which is the companion term for dust. What this would do is increase the amount of ventilation exhaust that would have to be placed inside this area to deal with these things. Now, dust in a micro distillery or even a microbrewery situation is almost never an issue. But it does come up, especially as people in the AHJ start to think about things. And, better to let them know that there's an issue or that there could be an issue and how it is resolved than to sweep the problem under the rug, so to speak, um, and find out later that then they find out on their own and bring it up. So the simple thing with dust is good housekeeping, and the code will require a dust hazard analysis, which basically sets forward a housekeeping program. You follow the program for a month, record how much dust you've accumulated. If the program is working, you won't accumulate enough to even test, and you will be deemed to have eliminated your dust hazard. So again, it's really kind of common sense. You want to clean up that mill room, and anywhere around it. Room design is an important factor. It makes it harder to clean if you've got a lot of little nooks and crannies. So we usually like to keep mills in a separate room with smooth walls that are, not painted tan. Either a lighter color, preferably a darker color, so you can see what you're cleaning. This is not the proper way to clean. All you're doing there is lofting the dust into the air. Proper ways to clean are with a static free broom, a mop, not these rags. Oily rags laying in a corner are sort of another problem in and of themselves, but really just damp rags are the best way to economically clean. If you do get into an operation that's large enough, the lower left-hand image is of an explosion-proof vacuum, which is going to cost a lot more than your regular shop vac. You don't want to use a regular shop vac because it essentially sucks whatever it is through the motor, which again, common sense is you don't want to suck alcohol vapor and dust through a sparking motor. And this is talking about the room design I'm an architect, right? So paint color is pretty, right? It's an important aspect of my artsy side, but it does have a practical application here. You want to have a higher gloss, so it's easier to wipe up with a damp rag, uh, and you want to use a contrasting color to what the color of the grain is going to be. Let's see. So we're talking about physical hazards, and we're getting into a few other things that we want to consider. So as far as safety goes in a distillery. Yeah, I'll let you read that later. And then we've got, hazards for hot liquids or, include scalding. This is, where mash cooking can come in. And, again, it's common sense. You don't want to get splashed with some hot mash. Um, and, even though mash is, under 20% alcohol is not really regulated, there are some risks that need to be taken care of. And now we're looking at some common sense things. And in this picture, we see the owner who unfortunately was very happy, but not so happy after his employees suffered a catastrophic explosion of this thing. which the company that made this thing is out of business, and I don't know that I would even call this a still. I mean, it's got square corners, crappy welds. There's a reason stills are round, because then it's got a uniform structural capacity to it, unlike something that's square. We've got um, a dryer vent there. This is a direct fired still. This is not real brick. This is that fake brick that's like an asphalt shingle. Just a lot of things going on there that really shouldn't be going on. And this was the before and the after. So fork trucks. And I'm going to tell you, there's some obvious hazards here with having to do with fork trucks, but the one that we get asked about mostly is, do I need to pay like double or triple for a static proof fork truck? And there's also, can I put my propane fork truck inside my warehouse? Well, no, not really. It's you should no more do that than you should sit in your car listening to your favorite tunes with the garage door closed and the motor running. Um, it's not as bad in a warehouse because it's big space, and as common sense would tell you, again, with things like CO2, alcohol vapor, a lot of it has to do with scale and the amount of air surrounding it. But the answer is, do I need an electric forklift that is explosion proof? The answer is no, if you can provide documentation that you have eliminated that classified area by providing more exhaust than could than alcohol vapor drive. Portable fire extinguishers are required by code. It's an annual inspection generally to make sure that they've been tested properly. Um, Usually a private company will do this for you, and then a fire department inspector might come by and just annually check that you've been doing this. The same is true with your fire alarm and sprinkler system. Um, Generally, the company that installs sprinklers and fire alarm systems will do a comprehensive annual testing of this. And often they'll also test you if you have any fire shutters, doors that close to form a fire barrier based on a heat activated fusible link. Those need to be tested once a year as well. Signage is an important part. It's not only required by the code, but it alerts people to the fact that, hey, in case you didn't have common sense to not to smoke next to in the barrel house, this will this will help remind them. And then, this is a code requirement. And when you do get this, you can read a little bit more closely about the sort of the meaning of these different diamonds. You'll see these everywhere. Basically, your alcohol is a 3, that's the physical hazard. There's some debate as to what the health hazard is for alcohol, but generally code says it's a 2. Um, and it's not an unstable liquid. And then this one down here is for special circumstances such as oxidizing material, and no alcohol isn't there. So we're really worried about this number 3 up here. Boilers. Most folks have a boiler to operate their mash tun and their distillation equipment. Electric distillation equipment and equipment is fine as well. And that's, you'll have some electrics with inside your sombrero, but again, if you eliminate that, the code allows you to eliminate that classified area if you can demonstrate that you can never exceed 25% of the LFL. That's usually done via a dust hazard analysis for grain producing equipment, and via the electric declassification for and ventilation for distilling equipment. But low pressure boilers are those boilers that operate at 15 psi or less. And depending on your jurisdiction, you may have an annual inspection of those. High pressure boilers operate at more than 15 psi, and we see the high pressure boilers in larger facilities more often than in smaller facilities. Some jurisdictions will require that there be a licensed operator that has to take classes and so forth to operate a high pressure boiler. So if you're working on deciding which type to use, that may be a consideration to find out if there's additional regulations for the high pressure boiler. But regardless of inspections or the legal requirements, they should be maintained and inspected by your operation per the manufacturer's recommendations. Stills are interesting. Sometimes we get AHJs, government officials that will say, hey, I want your still to be UL listed. Well, no one makes a UL listed still. But what they do make is UL listed components. They make a UL listed motor. They make UL listed sensors. And so that's where the education comes in, is explaining that this still is an assemblage of listed and tested pieces of equipment. Oftentimes this is colloquially referred to the pot as the boiler. Well, we don't want to call it that. And we also don't want to call your hot liquor tank a hot liquor tank. We want to call it a hot water tank, just because the term boiler connotates to people who aren't familiar with distilling a actual water or steam boiler. What is one of the most important things, other than getting properly designed and reputable equipment, is being able to demonstrate that that equipment is operating at very low PSI. You really know more than 3 PSI, and all distillers kind of know this. But if you can point to a valve, and by the way, the one I showed you, the picture I showed you of the Kentucky Silver Trails, that still exploded as a result of the manufacturer running out of 3 PSI pressure relief valves, going to the hardware store and buying a 100 PSI pressure relief valve that would be meant to go on a residential water heater. So you want to make sure that you've got the proper pressure relief valves in the proper area as per the manufacturer of the equipment, and that you can have a pressure, which most are going to have anyway, because you want to watch that, a pressure gauge that you can explain to your AHJ, hey, this doesn't work over about 3 PSI, and it'll never be over that. And besides, we've got electric interlocks that will shut it down if something goes wrong. So if you're going to be doing some welding on or near an area where there could be high concentrations of alcohol vapor, you want to have a standard operating procedure to issue what's called a hot work permit. A hot work permit is something that's issued by the facility to the contractor or employee that's going to be doing some grinding or welding in that area. It has procedures listed as to, hey, we're going to put a welding blanket over this. We're going to have someone standing by and spotting with a fire extinguisher. We're going to make sure that, whatever is right for your facility. Some jurisdictions will require that program of hot work permits issued by the facility be presented to the jurisdiction on an annual basis, so the fire department can have something to say about how you're doing that. A little bit about PPE. This is kind of in the realm of OSHA, and it's important to take the time to put on your gloves and wear eye protection, aprons, in some cases steel-toed shoes, but in most cases at least you're not going to want to be in there in your shorts and sandals. Usually people find out not to do that anyway the hard way when they drop a pipe wrench on their toe. But these are things that you should be aware of and your employees should be aware of. if there is a respiratory hazard, say maybe when you're cleaning a dusty mill room, it might be nice not to have repeated exposure to that. And so you would want to be able to use, the proper equipment. Hearing protection, it may be all right to walk around in a loud factory every now and then, but if you're there day in and day out, it could, you know, lead to something like tinnitus or some other hearing damage. Lockout tagout is something that most people might be familiar with. The idea being that, if you're working on a piece of electrical equipment and you want to make sure that the breaker is off. I don't know why they're putting three locks on this one. That may be a little overkill, but there's a procedure to make sure that someone doesn't accidentally flip that breaker on while you're in the middle of working on something electrical. The same might be true for confined spaces. You might put something in place that makes sure that you can't accidentally shut um, the man door on a tank while someone's inside cleaning it. Of course, they've got to wear the right kind of respiratory equipment and have a way to test what the air is inside those confined spaces. So employee training is the backbone of a safe and efficient distillery operation and building a safety culture. This doesn't mean that you have to be like, oh, gung ho and crazy. I think there's ways to make it understood that, hey, let's just do this. It's going to make our life a little bit better and potentially extend it. Um, so, I think we've got to the end of this, and there is some contact information for us and that QR code again. I think at this time I'd like to see if there's any questions.
Yeah, one of the questions that came in from Rusty really is about condensate return pumps and your experience with running into whether they they are included or cause a problem with having to be explosion proof as part of the overall attention to safety when it comes to explosion risks.
Yeah, that's a really good question. And gosh, it's almost Rusty like I could have planted that question for you, but I swear I didn't.
Well, you can thank Rusty for that.
Yeah, because the condensate pump, I'm trying to get back to that sombrero picture. The condensate pump is usually one of those things, best practices, we want to keep our electrics out of that sombrero, right? But there's always going to be something that it's just not practical to keep it out of that area. And the condensate pump is one of those things. All right. You can get an air activated condensate pump and put, if this is your still, it wants to be right down here. But if you do put this ventilation system in, and that ventilation system is designed to match the operation of your equipment, then you eliminate this altogether, and that condensate pump no longer is an issue. So what we usually advise people to do is like, okay, we're not going to move your condensate pump and make your boiler system not work right. We're not going to recommend that you pay more, although I've heard in some cases it's not that more for an air activated or an explosion proof condensate pump. But what we are going to recommend is that you put this, and in my opinion, if you eliminate the possibility of that fuel by having this exhaust there, that is a lot safer than designing electrical equipment that can withstand that explosion. I'd rather just not have the explosion or the deflagration than to rely on equipment to prevent it from doing damage.
So if I understand you right, from a code or from an inspection standpoint, if somebody said, "Hey, you got to have this," then you would advise the distillery to prove that the ventilation was sufficient to avoid it being a hazard in the first place, instead of immediately going to replacing the pump. Is that right?
Yes, and hopefully you have proactively done that when you've gotten your permit to do whatever you're doing from your local jurisdiction. I also want to talk about, which hill do you die on? So if you're in a situation and you've got it designed right and you've eliminated that classified area, maybe someone doesn't understand it, or maybe you haven't provided the mathematics necessary to prove that. And someone does come along and say, hey, you got to have an explosion-proof condensate pump. Well, if that's going to cost you a couple $1,000s, but it might cost you a couple thousand or more to put in the ventilation, and maybe it's easier just to kind of practice the yin yang theory of this and kind of go with the flow. It's sometimes easier, you might want to say to them, well, this takes care of that, but hey, I'm going to go ahead and spend 2 grand on an explosion proof condensate pump, if that's what it is. If it turns out that the explosion proof condensate pump or the thing that they're asking you to do is, makes it completely impossible to operate correctly, um, then you want to get into how you're doing something else that is equally compliant with the code or and actually safer, and explain that to them.
Gotcha. That, I mean, the other question we got, we kind of touched on, which was code and regulation related, which is going to be, federal plus state plus possibly having a good or not so good relationship with, whatever local authority is actually going to come in and do the inspection for you. It's going to be a mixed bag of of compliances, right?
It is going to be a mixed bag of compliances. And so you've got your TTB, your federal regulations, and then you've got a state component of the sort of the same thing. And obviously from state to state, those alcohol related regulations are going to vary. Those regulations um, are really easy to meet, in my opinion, compared to the regulations concerning building and fire codes. Those regulations, all they do is tell you that we will take away your DSP if you're found to be, or we won't issue it unless you can demonstrate that you're in compliance with your state and local regulations. Oftentimes, when we're working with startups, we'll have this, which comes first, the chicken or the egg? You're not allowed to have your TTB until you've got a code-compliant facility. But you can't have a TTB unless you're or a DSP unless you're making something. So we often get people asking, how should I time getting my TTB approved? And so we kind of want to put that. Long story short, if you do get your DSP before you're done with your construction and have full sign-offs, I've never encountered anyone saying that someone walked in and said, hey, you've given you a TTB, but you're still waiting on your fire alarm inspection, and so we're going to punish you. Um, so I wouldn't worry too much about that. You don't want to have your TTB before you really even get started with construct, or your DSP before you really even get started. But you have to follow the alcohol related production, or sales codes, I'm going to call them, which are the TTB and your state alcohol board. But then you also need to follow the zoning rules. A lot of places wouldn't allow you to have a micro distillery in a residential area, for instance. Some places have alcohol related I don't know, moral zoning laws about, hey, you can't have a bar next to a church or a school or something like that. So those are some considerations. And then on a complexity level above that, comes your compliance with your building and fire code. And so that's where, and OSHA also as you're operating. And that's where what we've been talking about with the safety. Again, there are many hurdles, and the getting the DSP is usually a big hurdle. Um, and then another one is making sure that you're in compliance with your state and local fire and building codes.
Yeah. Well, great. Well, that looks like that's it for the Q&A. Just as a reminder, Scott will email everybody the presentation. And of course, by nature of that, his contact info. If you had any other questions, I know a couple of people asked about the presentation. Also, once I get the video file edited and processed, I will email the YouTube link to everybody so that you can, at the end of this, you'll have Scott's standalone presentation and his contact info. You'll also have the link to the YouTube link for the entire webinar if you want to listen to it again or watch it again. Okay, so Amy, would you just get a question real quickly, Scott? Amy wanted to know, can you talk about storage in plastic containers a little bit more? You were talking about that the totes are good for transport.
Yeah,
but
yeah.
there were some limitations to beyond that.
Yeah, so in most jurisdictions we're going to be dealing, well, let's say in Midwest and Western jurisdictions, we're going to be dealing with the International Building Code and the International Fire Code. Due to the way that standard codes developed over the years, East Coast and Southeast jurisdictions often will follow the International Building Code and the National Fire Protection Association, NFPA 1. Regardless, they refer to NFPA 30, which is the code for flammable and combustible liquids. So when a code like the building code, the International Fire Code says, hey, you need to follow this standard, you then have to also sort of mesh in the rules from that standard. And so I think the slide that we have on that does articulate exactly where the regulation is found in the code dealing with plastic containers. And there is some logic behind this. If you have a plastic container, the container is going to, it will melt and release the flammable liquid. And so I guess people who have written the code have sort of, or NFPA 30 has sort of drawn the line. They're okay with the drums as long, not if it were gasoline, but if it's water miscible liquids like alcohol, which is, again, you might need to demonstrate that there's this special exception in the code for your alcohol in this, but it doesn't allow for the plastic tote. And you see them everywhere. This is a question I get all the time because so many distilleries have them. It doesn't, it's shipped in that. How can it be shipped in that? You can't get it shipped really. Well, you can, but it's going to cost a lot more to force one of these distributors to ship it in a stainless steel tote. So what we recommend is different operating procedures where you can say, well, our standard operating procedure is going to meet the code by allowing us to bring this thing in for 24 hours, during which time we're going to empty it into one of a stainless steel tank that we own. And then it goes back outside. And, there's other regulations about outdoor storage that would affect these plastic totes, but it may make sense for an operation to store full ones outside. It may not. It's really just going to depend on the situation and your size. So I hate it when I have to tell people that plastic totes aren't allowed because everyone has them. And there may be an opportunity to, within the code, there's most of the code is prescriptive based. And we like to use the prescriptive based code language because it's easy to point at it and say, right here, it says this. But you can also take a performance-based approach where the performance-based approach says, the code wants us to achieve an outcome. And it's up to the facility and the designers to figure out how best to achieve that outcome. So from a performance-based standpoint, you could achieve the desired outcome, which is not to have plastic totes melt and release alcohol, with by other means, by, keeping them in a room where there's no possible for there to be a flame or an ignition source, proper ventilation. You've got, maybe higher level sprinklers. The trouble with the performance-based approach is that you've got to get buy-in from the authorities having jurisdiction. And it really depends on the jurisdiction and your relationship with them as to whether or not they're going to have how high of a tolerance will they have for looking at special situations. And that's kind of a case by case basis, based on, do we have one plastic toad or do we have 100? Is our jurisdiction a great big city where they're understaffed and overworked and really can't vary from the code? Is it a smaller jurisdiction where there's more of a community atmosphere? So,
Gotcha. Well, Scott, thanks again for spending some time with us today and going over all of this. Thanks to those who attended for being here, and hope you learned something and got something out of it. And I really appreciate the partnership, Scott. Thank you.
well, thank you, John, and thank you, attendees. It's been a pleasure here, and hopefully I'll see you all again someday.
All righty. Sounds good. Thanks.